right, here we go. Division property of exponents. Here, let me grab my shade so we can focus our attention here. All right, letter C, division property of exponents. So we've already multiplied like bases. Now we're going to divide like bases. So again, here's another pattern that you have to learn. Another pattern that you have to learn. So you got to look for this pattern, and you have to apply the rule in this pattern. All right. Other class back there is being a little vocal. You don't need to draw this, but notice they both have an x for a base, right? The number below and to the left of an exponent is the base. The red is the exponent. Notice they both have an x. You can only use this rule when they both have an x. If they don't both have an x, you can't use this rule. So you're looking for two x's there. All right, how does the rule end up? With a single x. And then the rule says take the top exponent and subtract from it, I'm going to use blue here, the bottom exponent. That's the rule. X to the A divided by x to the B, we are dividing like bases, equals x to the A minus B. All right? X to the A divided by x to the B equals x to the A minus B. Let me show you why the rule works. So why does the rule work? Okay, we're not going to use the rule here. We're going to expand it. So 7 to the 5th means the base times itself 7 times, right? Base times itself 7 times. Let me get rid of this. In my controls. Okay, so here we go. So let's expand the base. 7 times itself 5 times. 1, 2, 3, 4, 5. Right? And the bottom is 7 cubed. The base times itself 3 times. 7 times 7 times 7. So we're doing it the long way. The rule will cause you to avoid doing it the long way. Okay, so take your red. 7 divided by 7 is 1, right? They go away. Take your blue. This 7 divided by this 7 is 1. They go away. Take your black. This 7 divided by this 7 is 1. They go away. What are you left with? 7 times itself 2 times, or 7 squared if we leave it in exponent form. Now let's use the rule. We'll do it down here. 7, right, the base. Take the top exponent 5 and subtract from it the bottom exponent 3. This is the rule step. This is what I'll be looking for you to show in each of the problems that you work with on this. I'll want you to show the rule step, and sure enough we end up at 7 squared. So the rule is simply a shortcut to writing everything out and dividing everything out. It's a shortcut, it's shorthand. But you got to make sure that you use it in the correct form, and that is when you have the like base. Anybody have a question? Mackenzie? Okay, when they say to expand it, like your homework said to expand it. So the very first thing we did on the video that you guys watched was expand. You had it in your notes a couple pages earlier. Like 5 cubed to expand would be 5 times 5 times 5. X squared to expand would be x times x, when they use the word expand. The only reason I expanded these was to prove to you that the rule works. It's the only reason I did this, was to get you to see that this is what's happening, but the rule gets you there a whole lot easier. That was the point of that. Dan?
So you're allowed to subtract exponents?
Sure.
You can only add them.
Well, again, same thing. Add a positive 5 and a negative 3, and you still get 2. It's the same thing. But yes, you can subtract exponents. Tucker?
I'm looking a little bit ahead on
Yeah, we're not there yet, so save your question until we get there because I'll probably answer it in the midst of teaching you. Okay, so number 2, don't go ahead. It's not wise. Then your notes don't look the way that we need them to look, and then you forget to show the rule step, and then we got issues. Okay, so here now we've got variables, right? Not a problem for number 2. Notice we have like bases. That's what you got to recognize. Notice we have division, Aaron. So we got to look at both of these things, like bases and division. And we say to yourself, okay, let's do the rule step. Take the like base. Here, that should have been green. Oh, this thing keeps jumping. Right? Take the like base. Do the top exponent. And subtract from it the bottom exponent. You can continue to the right. I like to go underneath when I can. And the answer is n to the 4th, right? And I hope you agree. So notice we're not going to expand it. The idea is to keep us from having to do all that expanding. And by the way, the bigger the exponents get, you don't want to expand. Then you get these big exponents. We don't want to deal with that. Okay. So I want everybody to try to do B. Show me the rule step. And then finish off D. We'll leave it in exponent form. Go ahead and do B. Leave it in exponent form. So one more time on 3. Give me your answer. 1, 2, 3.
8 to the 7th power.
Okay, so I heard a couple different things. All right, let's apply the rule. Base, correct? Top exponent. Agreed? Minus sign of the rule. Agreed? Bottom exponent. Agreed? Okay, we already learned that minus a minus is a... So why didn't you end up with 8 to the 7th power, right? How many of you did? Okay, you're the ones that have it correct. Questions? Yes.
Let's say we didn't have to divide 8 to the 5th power.
Okay, this the whole point of the problem is we're dividing. So there's no question without dividing. That's what we're doing right now. Other questions? Anybody else? Because it's a division problem, PK. I mean, that's what we're doing. So it is division. Got it, Aaron? All right, let's go on. 0 exponents. Say 0 exponent? Yeah, 0. Okay, so you guys remember the problem last night with the p cubed times the p? Do you guys remember that one? Right? It was p cubed times p. What was the exponent of the p? It was 1, right? Whenever no exponent is shown, it's always 1. Whenever no exponent is shown, it's always 1. Well, 0 exponent does get shown. So you'll see it. If there's a 0, we're going to have to show it to you, because if nothing's shown, it's a 1. All right, so what is a 0 exponent? Interesting. What is it? All right, so we got to figure out what a 0 exponent is. You might choose to do this. Don't worry about the raised dot there. That's just extraneous there. It kind of popped up in the middle of nowhere. All right, I'm going to do a little progression with you guys and see if I can get you to understand. So let's do x cubed. X cubed. We all agree it's x times itself 3 times, right? X times x times x. Nothing earth-shattering, right? We all understand that. Would it be okay if I wrote it x cubed over 1? Are you okay with that? Same thing? Isn't x times x times x, x cubed? Can I put it over 1? Is that okay with everybody? Can't you put anything over 1? Right, if you had the number 7, couldn't you make it 7 over 1? Okay. You'll say, why did you do that? I'll show you in a minute. All right, let's do x squared. So you know x squared is an x times x. And so if I wanted to, I could make it x squared over 1. Agreed? If we had an x, it wouldn't be shown, but it would be to the first power. Agreed? And it would be just an x. Yes? And if I wanted to, I could write it x over 1. All right, running out of space here. We'll make it work. Just leave x to the 0 there for a minute. If you turn your page, and you can if you want, and come right back, you're going to see we're going to do negative exponents. Huh? A negative exponent? Yup. A negative exponent. Huh. Negative exponent. Watch what a negative exponent equals. It equals 1 over x. Trust me, it does. And x to the negative 1 is 1 over x. And I'm just about out of room. I'm squeeze in x to the negative 2. I'm going to go all the way to the right first. X to the negative 2 is 1 over x squared. X to the negative 2 is 1 over x squared, which is the same as 1 over x times x. And I don't have room, but if I did x to the negative 3, it would look like this. That would be x to the negative 3. Okay. Now this is abstract, but some of you are good at patterns, and you see patterns. And if you see patterns, you can figure out what's going on here. So I want you to look at x times x times x, or x cubed over 1. So an x cubed, an x squared, an x times x, or an x squared over 1. An x to the first, an x, or a x over 1. Now we're going to come back to this 0. X to the negative 1 is 1 over x. X to the negative 2 is 1 over x times x. And x to the negative 3 is 1 over x times x times x. So when you have a positive exponent, you do the base times itself where? In the what? Talk to me if you know it. It's a positive exponent. You do the base times itself in the... Take a shot, take a guess. Can only be right if you try. You do the base times itself in the... If it's a positive exponent, you do it in the... I heard it. In the what? In the numerator. If it's a negative exponent, you do it in the denominator. Exactly. Okay. So what's the in-between? So let's think about this. Some of you know the answer. Some of you learned that something to the 0 power equals a value. Does anybody know that value? None of you had 0 exponents yet? You should have. You may not remember. What does anything to the 0 power equal? Does anybody know? Alejandro? It is 1. Okay, that's our final answer. It's our final answer. How do we get to 1? Okay, so watch. X cubed, 1, 2, 3 in the top. X squared, 1, 2 in the top. X to the first, 1 in the top. We know we're going to end up at a value of 1. So top, 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 bottom, bottom, bottom. So what's this in between right here? Tucker? What do you want to say? What over what? We went from top, 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 bottom, bottom, bottom. What's the middle? Sophia? Not 1 over 1. Not 1 over 1. Nathan? It is top over bottom. A 0 exponent means the base divided by itself. Isn't x divided by x 1? Yep. Look at the pattern. Top, 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 top and bottom, 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 bottom. Right? So it's all tops. Anything positive is tops, top, 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 till you get to 0, top and bottom, and then negatives, just bottom, just bottom, just bottom. That's the progression. All right, if I had more time, I'd deal a little bit more with it. I don't, but I'll show you how to work these. They're a little bit easier than, if you don't understand that, that's fine. All you need to understand is this. A 0 exponent is the base divided by itself. And if you need to put that underneath the blank, put it underneath the blank. But you need those words. A 0 exponent is the base divided by itself. So we're switching over from tops to bottoms. And that switch over place, that 0 exponent, is top and bottom. To switch over. We're going from tops. Now we're in the 0 place, top and bottom. And now we're going to bottoms. As you do positive and negative exponents. Dan.
If you were to do x, like 4 times 0, wouldn't it be 0?
We're getting ready to do some examples and then see if you still have a question, okay? Let's do a few examples. Tucker.
I heard you say it once, I just forgot. Is the top numerator and the bottom denominator?
Any fraction, the top is the numerator, the bottom is the denominator. Yes, top is numerator, bottom denom. Okay, so watch for A. Let's do the rule step. Can somebody tell me what to write the rule step? Raise your hand on it. Gavin?
17.
That is the correct rule step. The base divided by itself. So the base is 17, and he did the base divided by itself. That's what your notes should look like. When I want the rule step tonight, that's what you're going to show me. And ultimately, the answer is 1, right? Let's continue our progression. Somebody tell me what to write for the rule step on B. Krista Lee. Where? That is correct. 3AB goes on the top and 3AB goes on the bottom. 3AB over 3AB. Final answer, class? 1. Because anything divided by itself is 1. C. All right, C, we got a little bit of a different thing here. C is quite interesting here. Let's not be as complex of a C because I don't want to mess you up right away. Let's make this the C. Go ahead and just cross it off. Let me go like this. We'll save that one for Algebra 2. Okay, this next step. Don't write anything yet, but what do you think is the final answer to this? On 3, I want you to tell me the final answer. Okay, think about it. If you got an answer, give it. If you don't, that's fine, but if you got one, give it. Here we go. 1, 2, 3.
1 and 2x.
Okay, I heard 1. I heard 2x. Did I hear anything else? So how many had 1? How many had 2x? Okay, a couple of you. And I don't know what you said, Aaron, but it was one of those. Okay, that's fine. Okay, everybody's wrong. Did you hear what I just said? Everybody's wrong. Figure out why you're wrong. Everybody's wrong. I want you all to think. Try to come up with another answer. Raise your hand and tell me what you think the answer is, and we'll see if we can get everybody going. Everybody's wrong. Jed, what do you think the answer is?
2.
Incorrect. 2 is incorrect. Kim,
-2x
final answer. What's -2x over -2x? That would be 1, and 1 was the wrong answer. Okay? So, answer. Mackenzie. 0. Still not correct, but at least you tried. Hey, you can't be right unless you try. Diego. Not infinity. Not infinity. PK.
-2.
-2 is the answer. Why is -2 the answer? Listen, Leah, go ahead.
Because the 0 is the exponent for x, and so it cross out those, but -2 is the
Remember how I said in the beginning, be careful that you only do the exponent to its base. So here's what we really have. We still have the -2 times the x divided by itself, right? That's what the 0 goes to. And therefore now we end up with negative 2 times 1 for a total of negative 2. Okay. The difference here was, you see in B, everything is in the parentheses. So that's the difference, right? You got to keep track of what is and what is not the base. Hope that makes sense. Does it make sense now that you see it? Am I with you? Are you with me? Okay. On D, we have this issue. Do you agree this is the rule step?
Yes.
Do you remember what the answer is when that's the case?
Infinity.
Not infinity. This one is no infinity. This one is undefined only. This one is only undefined. A number divided by 0 is infinity or undefined. But 0 divided by 0, that's the one that nobody knows. All right. Dan.
So, like, if you were to normally do, like, 17 times 0, you get 0.
But that's not a 0 exponent, Dan. Remember, the exponent tells you how many times to multiply the base times itself. A 0 exponent says, don't multiply the base times itself 0 amount of times. Don't do it. It tells you it's really a 17 divided by 17. Right? That's a exponent tells you how many times to multiply the base. For example, Dan, if you had 7 squared, the answer is not 14. It's not 7 times 2. It's 7 times 7. So when you have a 0 exponent, it's not 17 times 0. It's the base divided by itself. Different concept that you have to get in your thinking. Okay. Think about it for a while and see if it begins to make sense. All right, let's go to the last page here. All right, where are my negative exponents? Where are you? My page is gone. Great. Okay. Oh, yes. Love it. Okay. So, negative exponents. Negative exponents. So, we just dealt with these. So, this negative right here, it says this. It says, do the base to its exponent in the denominator. If you want to write bottom, that's fine. In the denominator. That's what that negative says to do. So x to the negative a equals 1 over, use your green here, x. And now instead of it being negative, it's positive. X to the negative a equals 1 over x to the a. Here's the bottom line. A negative exponent, the base to its exponent in the denominator. The base to its exponent in the denominator. It's no longer negative. And again, don't be thinking multiplication. It's no longer negative. Let me see if I can show you what I mean. Okay, so we're going to use the rule step here. So because it has a negative exponent, I need a 1 on the top to show it's a fraction. I need the base 3 in the bottom. And what do I write as the exponent? Talk to me. 2. Goes from a negative to a positive. So 3 to the negative 2 is 1 over 3 squared. And so if I get it to a final value, it would be 1 what? 1 what? What's 3 squared? 1 over what?
9.
1/9, right? Would be the final value of that. 1/9. With numbers, we can get values. With variables, we have to leave them. So this 7, n to the negative 7, means it's n to the positive 7 in the denominator. N to the positive 7 in the denominator. Okay, I wish I had a couple more minutes. I'll deal with this a little bit more tomorrow. But listen, a little bit of mental math. If I had a to the negative fifth, what does that equal? Talk to me. A to the negative 5 equals what? 1 over what? A to the fifth power. Let's try it again. T to the negative 7 equals 1 over t to the 7th power. 39 to the negative 2 power equals
1 over 39 to the 2nd power.
Okay? That's the idea, and that's the rule, and that's what you need to learn. Okay, well, here's one other part. So again, I wish I had a couple more minutes. But I want you to look what happened. A negative exponent in the top becomes a positive exponent in the bottom. Did it not? What if I want to take this positive exponent in the bottom and I want to bring it up to the top? Here's the key now, listen. Anytime you take a base and its exponent across a fraction bar, up or down, doesn't matter. You change the sign of the exponent. So if I want to take y to the 5th from the bottom and put it in the top, what would it be in the top? It would be y to the negative 5th. Whenever you take a base and its exponent across the fraction bar, you have to change the sign of the exponent. Now, I will tell you this. Normally, we don't want negative exponents. It's not a good form. But we're trying to get you to see that you can take things across the fraction bar. So, the 7. What's the exponent of the 7 in the bottom? It's positive 1 in the bottom, right? What's it going to be? What's it going to be when we put it in the top?
Negative 1.
It's going to be negative 1. And there we got to show the 1, right? You just can't have 7 with the negative sign, right? You got to show the 1. 7 to the negative 1. All right, compound problems. Are there any there? Okay, real quick. What's the rule? Z to the 2 times 3. Simplify. Z to the 6 times Z to the 5th. What's that rule? Z to the 6 plus 5. See how I use 2 rules? So again, I know that's tricky, so this is Z to the 11th. Notice how I showed the rule steps. Second example, x to the 5 plus 3 divided by x to the 2 times 3. Those are 2 different rules. Gives me x to the 8th divided by x to the 6th. What's the rule on x to the a divided by x to the b? Talk to me. First rule we did today. X to the a divided by x to the b equals x to the a minus b. So it's x to the 8 minus 6. Final answer, x squared. Your rules are tricky. You guys have to get used to them. That's why every time you do a rule, I want you to have the rule step. You need to see the pattern. Which kind is this? All right, you got your homework at the bottom. Quiz tomorrow.